Okay, so first of all, same common course, the CO, which is geometry, G for geometry, congruence, and I think it's number 10, which is using theorems to prove properties about triangles. That seems to be the same one over and over and over again, but that's okay. It's all good. So, I'm going to need some graph paper as I do number 1. And if you guys don't have graph paper, then I will just I'll pass my notebook around if you need it. Anybody need graph paper? Okay, there you go. Pass that around, okay? So, number 1. Perpendicular bisector. Let me go ahead and graph it first. Yeah, a little graph in here.
You said no. Hey, quiet.
Okay. So, let's think about it. Perpendicular means 90, right? And bisector means in the middle, okay?
Thank you so much.
So we got to be at 90 degrees and in the middle. So the line I'm looking for is probably something like this. See my orange pencil? It's going to look like this, right? So it's got to be 90 and it's got to be in the middle. So probably my orange pencil is right about where it's supposed to be, okay? So we need to come up with that equation. So before we do anything, we're looking for the equation of a line, y equals mx plus b. Let's just start there. We know the answer's got to be some y equals mx plus b for the line I'm going to draw. So what I need to do is a couple things. One, first of all, bisector. Let's find the midpoint of AB. To find the midpoint, the easiest way is just to count, right? We're going to count up and over and then go half that distance. So, and there is a midpoint for them, but let's just count. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So I went up 8 and over 6. And then as far as a midpoint, that'd be just half of that, right? So 8, 6, let's just go 4, 3. 1, 2, 3, 4, 1, 2, 3. So there's my midpoint, okay? I know then the line's got to go right through that. There's my bisector, okay? How am I doing? Capiche? Okay. Now the next part has to do with perpendicular, which is 90 degrees, right? But we can't draw a 90-degree angle. What we need to do is really make a perpendicular line, okay, which means opposite slope. So we're looking at opposite slope. Okay, so let's figure out what the slope of AB is. Okay, that slope is up 8 over 6, which is the same thing as up 4 over 3. So 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. So it's up 4 over 3, right? Now, to have an opposite slope, the slope we really want is we're looking for the slope that's going to be at slope perpendicular is going to be negative 3/4, okay? How am I doing so far? So I took this slope of AB and I made a perpendicular slope by flipping it upside down and making it negative, okay? So that's my slope. So let's go ahead and try and do that. So we're going to go from our midpoint down 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And I'll do the opposite. I'll go 1, 2, 3, 1, 2, 3, 4. Okay, and I'll draw my line. Now, it looks like it goes through 0, 0. It doesn't exactly go through 0, 0, but I will take that for right now. And I'll show you how we can get the exact answer. So the answer looks like it's probably going to be y equals negative 3/4 x plus 0. Okay, sure looks like it, doesn't it, right? Because it looks like it goes through 0. If I use my equation, I can find out exactly. It might even be negative 1/4. So to get the exact answer, the exact y-intercept You guys did this in algebra. I know you did with Mr. Bard. You take our y equals mx plus b, and let's solve for b. Okay, remember doing this in algebra? So let's take our point, and our point is at 1, negative 1, which is an x and a y value. Remember? That's an x and that's y value. We know our slope is negative 3/4. So if I plug these numbers in, negative 1 equals negative 3/4 times a 1 plus a b, I can find out what b is. You guys remember doing that in algebra at all? We screwed it up so you see it. Remember doing that in algebra? So I'm just going to solve it, and I'll have a negative 1 equals a negative 3/4 plus b. I'll go plus 3/4. If I add 3/4 to negative 1, negative 1 plus 3/4 is what? Negative 1 plus 3/4 is what? Negative 1/4. So the real answer, and I'll take this tomorrow because this is not an algebra class, but the real answer should be y equals a negative 3/4 x minus a 1/4. Okay, that is a better answer. Okay, we can do it geometrically tomorrow, and if you just get it close, I'll give it to you. But the exact answer is negative 1/4. Okay, remember doing that in algebra 1? Maybe. Ben says maybe. No. Okay. Kurt says no. Okay. I'm finding that more and more with kids, right? And there's some kids in algebra 2 that are having a really hard time because they didn't do anything in algebra 1, so it catches up to you. Okay, let's take a look, but I'm glad you guys are honest. Okay, 2, given triangle QRP where Q is 0, 8. So let's find the centroid, okay? Let's graph this. Hey, Kurt, we're learning it this year, aren't we?
Oh, yeah.
Yep. So let's go and do number 2, graph paper. 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. There's Q. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. There's R. And then 3, 0 is P. All right, draw that in. Okay, the centroid comes from the medians. So the median is just the middle. It's just the middle of the opposite side. So how do we get the middle of the opposite side? Well, I just count. That's the easiest thing for me. But I'll wait for you to get caught up before I do it, okay? So graphed. The medians means midpoint, right? Midpoint of each side. So let's see, this from here to here, I'm going to go over 1, 2, 3, 1, 2, 3, 4. I'm going to do half that, so I'm going to go 1.5 and then 2. So there's the midpoint right about there. I go over 1.5 and up 1, 2. It's right about there. There's my midpoint, okay? And then let's see, QP down 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. So let's go 4 and 1.5. 1, 2, 3, 4 and 1.5 is right about there. Okay, and find the midpoint of this one. Let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So let's go 3 and 2. 1, 2, 3 and 1, 2. Okay, so those are the midpoints. So let's just draw in all of our medians. Okay, median. Sounds fun next door, huh? You guys are doing math, you lucky kids. There it is. So there is our centroid, and it looks like it's about 3, 4. So the centroid is at the point 3, 4. Okay. Yeah, great question. I'm gonna walk it. So let's do this one's the easiest. Okay. So Jaden, let's do a journey. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So 6, 4, but midpoint's got to be half that. 6, 4. How about 3, 2? So let's go 1, 2, 3, 1, 2. There it is. Put that right there, then I draw my line, okay? Same thing here, Jaden. I went 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. So half of 8, 3 is 4, 1.5. 1, 2, 3, 4, 1.5. There it is. There's that one, okay? Okay, so midpoint is like in the middle. So the easiest way to find the middle is to go half the journey gets me to the middle, right? Okay, thumbs up, one thumb up, two thumbs up, sideways. Okay, all right, good. Okay, I like that one. It's like I'm almost there, right? All right, number 3. Let's find the orthocenter. All right, I can do that. Okay, hi Nicole. You need one of these, which are right here. Okay. So let's go ahead and graph JKL. So number 3, -4, 1, 2, 3, 4, 1, 2. There's J. -2, 1, 2, 3, 4, 5, 6. There's K. And 2, 2 is L. Okay, go ahead and graph that in, you guys.
What's the answer to number 2?
Oh, it was at the point 3, 4. Okay. All right. We just did this on a warm-up, right? Okay, so orthocenter. We're looking for altitudes. Which are going to be perpendicular, right? Which means opposite slopes, right? Okay, those are all the things I'm going to do, okay? To be orthocenter, we're looking at altitudes. So we're looking at perpendicular lines, right? So the first one's easiest. Okay, straight down from K, right? Perpendicular, boom. That's the easy one right there. 90. Now, let's do a little bit of sloping. You guys want to do some sloping? Okay. This slope is up 2 over 1. Up 2 over 1. See that? This one's up. Am I going too fast?
Yeah.
Okay, I'll wait for you. I don't want to get too far ahead. You guys work on this while I wait for everybody, okay? Opposite slopes, right? Opposite slopes, and you should be able to find it. Give me a thumbs up, Jaden, when you got it.
Do I need to write altitude?
Nah, not unless you want to. Okay, ready? So, straight down, 90, right? You got that one? That one makes sense, right? Okay, now the next one, watch. If it's going to be perpendicular to this line, it's got to be opposite slope. So this slope's up 2 over 1, up 2 over 1. So from here, instead of up 2 over 1, let's go 2, 1 this way. 2, 1, because it really is down 1 over 2. Opposite slopes, and then I think I've found it. I mean, I really have, but I'm going to do all 3, right? And you guys need to do all 3, but I think I've found it. The same thing on this line. It has a slope of down 1 over 1, down 1 over 1. So the opposite slope would be up 1 over 1, up 1 over 1. Okay. So opposite slopes. So then I draw them all in. Put my little 90s all the way around. And there's my orthocenter right there. So my orthocenter is sitting right there in the middle. And that coordinate is at -2, 4, isn't it? How am I doing? Thumbs up. 2, 1. Sideways.
This one is downhill.
Okay. I don't want that. Okay, you ready? 90 degrees. Straight up 90, right? Now, are you watching? This is actually, you're going to get it up 2 over 1. For this line, up 2 over 1. So the opposite of up 2 over 1 would be 1, 2 that way. 1, 2. Opposite slope. This one's like down 1 over 1, down 1 over 1. So this slope's got to be up 1 over 1, up 1 over 1. So when you get these opposite slopes, you're going to get 90 degrees. It has to be perpendicular to that line. And then I get them all at the intersection at that point, okay? Okay. All right, what do we got next? Okay, number 4. Perpendicular bisectors. So that tells me quite a bit, actually. If they're perpendicular bisectors, then we've got, in a sense, a circle that was drawn around this thing, okay? When we constructed that, remember how we did these before? That was the not the orthocenter, See, I don't even have all these memorized. And I took them off the board, doggone it. So here's what I know. Perpendicular bisectors. So I do know that these sides are cut in half.
Not the circumcenter.
Is that called the circumcenter? Thank you. Somebody knows. Kurt, you're probably right. I'll go along with that, okay? So, find KL, okay, QJ. QJ is easy. We can get that one right off the bat. You ready for QJ? Okay. This is 9.1. This has to be 9.1 because they're radius of the same circle. So QJ is 9.1. I know that for sure. Okay. KL. Don't know if I gave you enough info. Oh yeah, to get KL I got to use some Pythagoras theorem. I can do that. Okay, you ready for some Pythagoras theorem? I know that's 90. How do I know that's 90? See that word there? So do you see a little mini right triangle right here?
Yeah.
I do. I see a little mini right triangle there. So let's do a squared plus b squared equals c squared. So let's go 5.8 squared plus b squared equals 9.1 squared. How am I doing, okay? See that little mini right triangle? A squared plus b squared equals c squared. I need a calculator, don't I? Hold on. Let's see. So let's go 9.1 squared minus 5.8 squared, right? Bring that over, right? Subtract them. And then I'll take the square root of that. So we go square root of that. I get about 7. Awfully close to 7, okay? So B is about 7. So that means this side's 7, which means this side has to be 7 also. Did I go too fast on that? You guys know Pythagoras theorem, right? Right, Nicole? So, yeah, it's got to be 14 then. So if we take a look at KL, KL is 14, okay? KL is 14. I got that one, 9.1 there. And then finally, we need angle JQL. JQL. We need this angle right there. Okay, well, I know that's 40 degrees. Okay? I know that's 40 and that's 40. Okay? So then that's 36. So I can get that angle there. So I'm going to go 90 minus 40. I got that angle to be 50. I can get that angle there. 90 minus 36. What's that, 54? So that angle's 54. And if I add them together, I get 104. And I'll go through that again so I don't confuse you, okay? Ready? Actually, I did make a mistake. I made a mistake. It's Monday. That's got to be 36. That's 36. Okay, I made a mistake. Let me show you how. Okay, you ready? Watch. And this answer is wrong. That is not. I got to fix this. That's 54 also. Okay, here's what I did wrong. These two angles are not equal. Okay, but this is equal to that. You guys agree this is equal to that? That side's equal to that, so that angle's equal to that. Okay, so 36, 36, right? Which makes that 54, makes that 54. Sorry about that, you guys. Let's get this right. Be 108. Okay, do you see how I made my mistake? It's a nice sausage triangle, isn't it? Which means these angles are equal. So that makes that 54, and that's 54, and then add them together, okay? Do you want me to show it one more time? Okay, you ready? So, Jaden, here's what I know. Okay, that side's equal to that side, right? Which means that angle's equal to that angle. So if that's 36, that's 36, okay? Then I can get that angle because these two have to add up to 90. So I subtracted from 90 here. 90 minus 36
That's this one.
gives me 54. And then, of course, that's also got to be 54. Then I went 54 plus 54 gave me the 108. Okay? That's a little harder, isn't it?
Yeah, that one is hard.
Yeah. Okay, number 5. How am I doing? So on number 5, let's look at a couple of things. Right? 18 is bigger than 10, right? 18 is bigger than 10. So that means that 3x plus 10 is smaller than 30. Okay, so it says a range of values. So the first thing we're going to do is take our 3x plus 10 and make sure this is got to be less than 30. Has to be less than 30 because this angle is smaller than 30. Does that make sense? So for sure, 3x plus 10 must be less than 30. So we're going to solve for it. Minus 10, minus 10. 3x is less than 20. How am I doing? Divide by 3. Divide by 3. Divide by 3. X is less than, what's that, 6 2/3, I think? Now it says a range. It says a range of values. That means that there has to be a bottom side to it, top side and a bottom side. So let me show you the obvious. And now it really is obvious. See this angle here? Everybody looking at this angle? Everybody look right here. This angle right here. It can't be 0 degrees. If this angle was 0 degrees, and it can't be negative, if it was 0 degrees, you wouldn't have an angle. You agree? So the other side of this whole thing is to say that 3x plus 10, it has to be greater than 0. Because if it's 0, no angle, right? So I make sure it's bigger than 0, so I solve that. I got 3x is greater than negative 10 because I subtracted 10. Divide by 3, divide by 3, x is greater than negative 3 1/3. Right? So there's my range. If you want to get really fancy, you could write it like this. That's the way I like to write it. So it really does show it as a range. So that value has in between negative 1 1/3 and 6 2/3, okay?
Can you go over what you did for the first one?
Yeah, absolutely. I know that this angle is smaller than that angle because this side's smaller than that side, okay? So this angle is smaller than 30. So 3x plus 10 has to be less than 30. And then I just solved, okay? You got it, Keisha? Does that make sense? All right, number 6. Okay, what do I know about number 6? 2 ways to get it. One is Pythagorean's theorem. That would be the long way. Or another way. Yeah, you both, yeah. Claire's helping you out by pointing right there, and Katie already gave you the answer, right? 10 squared roots of 2. It's that easy. If you want to use Pythagorean's theorem on this one, go ahead, but I would rather just go 10 and 10 squared roots of 2. Okay, thumbs up on that one. Was that as easy as you thought? Okay. How about B? 60, 30, 60, 90, right? What do we do?
Divide 18 by 2.
This is twice as big as this, so this is 9. And then y happens to be what?
9 squared root of 16.
Yes. You guys get it? Everybody good? Jaden, nice job. Yep. Okay, C. Right? It's another 30, 60, 90, but the 12's in the bad spot. The 12 is sitting right where the x squared root of 3 is, right? So let's divide by the square root of 3. So we divide by the square root of 3, divide by the square root of 3, and we're going to cheat. We're going to go and put the answer down without doing it mathematically, but it's just going to be 4 square roots. It's going to be 4 square roots of 3, okay? Because 3 goes into 12 4 times, and then we tack on the square root of 3, okay? And we learned how to do that in algebra, and we're going to learn how to do it again in algebra 2, okay? So just trust me on that one, okay? Does that seem easy? Shayla's like, yeah. Okay, you guys ready to turn the page? We're getting there. All right. Okay, 7. They're medians. So that's our 2/3, 1/3 thing. If it's medians, we're cutting it into thirds, okay? So if it's medians, these lines are cut into thirds. So Vx is 204. So the first thing on that 204, I'm going to take my 204, little side. I'm going to take my 204, I'm going to divide it by 3, okay? Because I'm going to divide it into 3 parts, okay? The whole thing across is 204, but I'm going to divide it by 3 so I get the thirds. So I don't know. Let's see what that is. Clear 204. Nice job, Katie. Katie says 68. So if I go to this darn thing, I know that this is 68, and this is 2 of the 68s, right? So this is 136. Okay, so I got 68, 68, 68, okay? I know RW is 104. So that's 2/3 of this. So if I take half of the 104, which I think is 52, right?
Yes.
That means that this has got to be 52. Am I making sense? Am I doing it right? You guys see what I'm doing? I'm thinking thirds, okay? thinking take this thing and divide it in thirds. 68, 68, 68, 52, 52, 52. That's why I had to divide this in half, okay? So then, VW. See, VW is 136, right? WY is 52. RY is 104. And VX all the way across. We already had VX. Huh, that's a silly question. I'm going to make sure I don't do that again tomorrow. Ask the question of a piece that you already have, huh? So think thirds, okay? Think thirds. Okay, you ready for the last one, number 8? Mid-segments. Okay, now if they're mid-segments, two things happen, okay? Two things happen. One, if they're mid-segments, then it's right in the middle, right? And we also know, actually there's three things. Mid-segments cuts it in half. These lines are parallel, and this side is half this. This side is half this. So, if it's a mid-segment, you ready? This is 53. This is 53. This is 45. This is 45. 45, 45, because it's mid-segment, right? If that's 45, 45, then this is also 45 right there. How am I doing? Hey, girls. What you got? ASP today?
Yes.
Oh, okay. So, let's do this, okay? So, ZV is 45. Do you see how I got the 45? This whole thing's 90. Okay? This whole thing is 90, and that's half of that. Okay? This whole thing is 90, that's half of that, okay? PM, well, that's 53, 53, right? That's 106, right? And angle RZV. RZV. That's that angle there, huh? RZV. RZV. No, I'm wrong. RZ. I got the wrong one. RZV. That one right there, okay? And yes, it is 36. See the parallel lines, you guys? See the Z, which makes alternate interior angles, right? You guys see the Z? So that's 36. That's 36 degrees, okay? All right, so here's the moral of the story, easy moral. Hang on to this. Don't lose this, right? Keep this for tomorrow. We got a little bit of homework for you guys to do, and then... What's that? 36 degrees. Okay. Got a little bit of homework, and if you get done with the homework, then let's work on the hot air balloons, right? Okay.